Good evening, all. This is Guthrie Prentice, your friendly magician who is running for Member of Parliament for Victoria again. I thought I would do something a little bit more apt, shall we say, in helping people actually learn how to deal with things like the Ottawa shooting in a more effective method. There's been a lot of debate lately about whether he was a terrorist or whether he was just mentally ill or criminal record was the influence, what have you. Well, since normally one cannot make a, one cannot make a assessment from a single data point, especially with regards to bringing in tightened security legislation or assuming that we are weak to terrorist attacks because of one shooting him on Memorial Hill, I figured that sometimes we can actually look for combined data from other areas using Bayes' theorem or Bayes' rule, which is used to calculate conditional probabilities. And so I thought that what I would do is I would read this out and then see, as an exercise for the student, if anyone could figure out how to apply this to the Ottawa shooting case, specifically pertaining to what the most likely scenario was that motivated the man to conduct the shooting and what the appropriate response is. As in, what scenario is the most likely in terms of weakness, and therefore, where do we devote the most resources? So, for that, to that end, Bayes' theorem, aka Bayes' rule, is a useful tool for calculating conditional probabilities. Bayes' theorem can be stated as follows. Let A1 through AN be a set of mutually exclusive events that together form a sample space S. Let any B event be from the same sample space such that probability of B is greater than 0. Anyway, basically this is the math for you to be able to figure it out. But let's actually do a proper example in terms of a wedding or what have you. So, example 1. Marie is getting married tomorrow at an outdoor ceremony in the desert. In recent years, it has rained only 5 days each year. Unfortunately, the weatherman has predicted rain for tomorrow. When it actually rains, the weatherman is accurate, correctly forecasts rain 90% of the time. When it doesn't rain, he incorrectly forecasts rain 10% of the time. What is the probability that it will actually rain on the day of Mary's wedding? Solution. The sample space is defined by two mutually exclusive events. It rains or it does not rain. Additionally, a third event occurs when the weatherman predicts rain. Notation for these events is described below. Event 1, it rains. Event A2, it does not rain. And event B, the weatherman predicts rain. So the probability of A1 is 500 over 365 because it rains 5 days out of the year. The probability of it not raining is 360 out of 365 because it does not rain 360 days out of the year. Probability of B given A1 is when it rains is accuracy of 90%. And the probability of him being inaccurate is 0.1, or 1 in 10 that he will inaccurately predict rain. When it does not rain, he predicts rain 10% of the time. Therefore, we want to know probability of A1 given B, the probability that will rain on the day of Marie's wedding, given the forecast for rain by a weatherman. The answer can be predicted as shown below. Probability of A1 given B is the probability of A1 times the probability of B given A1 over the probability of A1 times the probability of B given A1 plus the probability of A2 given the probability of B given A2 times the probability of B given A2. In this case, it would be 5 over 365 times 5 over 365 times 90% divide by 5 over 365 times 90% plus 360 over 365 times 10%, which gives us in total 0.111% or about 11%. Note that this is a somewhat unintuitive result. Even when the weatherman predicts rain, it only rains about 11% of the time. Despite the gloomy weatherman's prediction, there is a good chance that Marie will not get rained on at her wedding. So either she, so the problem is though is that again, despite the fact that he's accurate 90% of the time, contrary to that, the likelihood of actual rain is only 11%. This actually holds true well for when you're determining the likelihood that a person has a disease, given that they've had a, say, 95% accurate test, given the actual prevalence of disease in the population. So that could be applied to the Ottawa shooter's mental health case. It could also equally apply to what are the actual prevalent numbers of ISIS involved in Canada from what we know. Now, that's an unknown factor, and that will require more advanced forms of Bayesian analysis, including Bayesian factors. But the point is that one can now calculate the conditional probability that the shooter was in fact a terrorist, or was in fact mentally unstable, or both. It is possible there might be some intersecting events going on here. So one can calculate the exact probabilities of each of these events. And even from that, one can actually determine the likelihood that just because we had one shooting of this case, one could look at past RCMP and determine how likely it is, given the laxity under current laws, that it will happen again relatively frequently. By applying this theorem, perhaps we might be able to actually determine what is the best course of action in terms of laws and where we actually should allocate our resources. Anyway, that's my thoughts on the Ottawa shooting with regards to mathematics. I'm not proposing that I have any of the right answers here, only that this might be the appropriate technique to address the issue. I'm looking forward to fellow people out there with political and mathematical backgrounds to apply this formula and actually provide some heart on this particular issue. Catch you later, everyone. And remember, if you live in Victoria, vote Guthrie Prentice for independent MP for Victoria, BC in the upcoming 2015 election.